Hi everyone, my name is Tan. My group member and I are going to carry out a presentation and the topic is IEEE Standard 519. This is an assessment given by our lecturer. The first IEEE Standard 519 was established in 1981. The title is IEEE Guide for Harmonic Control and Reactive Compensation of Static Power Converters. It introduced the basics of harmonics and quantifying factor for harmonics. Besides, it focused on the line knot limit, voltage distortion limit, telephone influence limits, and flicker limits. The second IEEE Standard 519 was established in 1992. The title is IEEE Recommended Practice and Requirements for Harmonic Control in Electrical Power System. It is deeply discussing about the harmonic. Besides, it introduced the total harmonic distortion and total demand distortion. It is focusing on recommended practice for consumer and recommended practice for utility operator. It is also evaluating new harmonic sources. This is the latest version of IEEE Standard 519. It was established in the year of 2014. The title is IEEE Recommended Practice and Requirements for Harmonic Control in Electrical Power System. In this version, it does not discuss about the harmonic fundamentals. It is more on the clarification and limit setting in nature. Besides, it focuses on harmonic measurement, recommended harmonic limits for voltage and current distortion. So now we are going to compare the two different versions of IEEE Standard 519. In the 1992 version, the harmonic effects can be reduced at any point in the entire system. The PCC is a point of metering or any point as long as both the utility and the consumer can either access the point for direct measurement of the harmonic index. And for the industrial plant, the PCC is the point between the nonlinear lot and other lots. Now we look at the version in the year 2014. It is clarified on the PCC. And the limit in this recommended practice are intended for application at a point of common coupling between the system owner and the consumer. PCC is usually taken as the point in the power system close to the user where the system owner or operator could offer service to another user. In this version, we know that for the industrial user, the PCC is at the high voltage side of the transformer, while for the commercial user, the PCC is commonly at the LV side of the service transformer. For the left hand side is the industrial user. We can see that the PCC is located at before the high voltage side of the transformer. And look at the right hand side, we can see that the PCC is located at the lower voltage side of the transformer. Next, we discuss about the responsibility. In the version of the year 1992, it is stated that users have not to degrade the voltage of the utility serving other users by requiring nonlinear currents from the utility. And the owner has the responsibility to provide users with close to a sine wave of voltage. Well, for the version in the year of 2014, the owner and users share the responsibility for the harmonic control between the systems. All users must limit their harmonic current emission to reasonable value, and the system owner has to take the action to decrease the voltage distortion level. For the version of the year 1992, it has 10 references. All the references are reference to IEEE standards and ANSI, American National Standard. Well, for the version of the year 2014, all the references are reference to the IEEE standard. It has 4 references, 3 IEC standard and 1 IEEE standard.
This is my turn to present about the limitation of 519-2014 IEEE standard. There are some of limitation to achieve the perfect sinusoidal wave. First, the limit must be set for the steady state operation. Second, transient condition exceeding this limit may be encountered. Third, should be applied at interface point (VCC) between system owners or operators and users in the power system. And lastly, it cannot be applied other than VCC. Harmonic voltage limit. Table 1 show that the voltage distortion limit. Uh, we must know the bus voltage V at VCC. We show the individual harmonic and total harmonic usage THD. So at the PCC, the system owners or operator should limit line to the neutral voltage harmonic. So first, at daily 99 percentile, very short time, about 3 seconds, values should be less than 1.5 times the value given. And second, weekly 95 percentile, short time, about 10 minutes, value should be less than the value given. B. The current distortion limit. General observation is newly defined limit based on 3 percentile. First, daily 99 percentile, a very short 3 seconds. Second, weekly 99 percentile, short time about 10 minutes. Third, weekly 95 percentile, short time about 10 minutes. So TDD must be up to the 50 orders only. The maximum demand current value is established at the PCC and should be taken as sum of current by demand during the each of the 12 previous month divided by 12. C. Current distortion limit for the system normally rated 120 volt to the 69 kV. So the table 2 show the current distortion limits for the system rated from 120 volt until 69 kV. So actually for the this they both of these same except the TDD calculation must be up to 50 harmonic orders. So even harmonic are limited to 25% at the old harmonic limit. And then current distortion, the result of DC is offset. For example, half wave converter are not allowed. All power generation equipment is limited to this value of current distortion regardless of the actual ISC divided by IL. So ISC means of the maximum short circuit current at PCC, and IL means maximum demand load current at the PC under normal load operating conditions. So for the D is we must see a system current distortion limit for the system normally rated above 161 kilovolt. So the table 3 show the current distortion limit for the ISC divided by IL must be limited to 25% of the odd harmonic limit. So all power generation equipment is limited to this value current generation regardless of actual ISC divided by IL. So that's all for me.
So hi, so today I'm gonna talk about the graph and the implementation of IEEE 519. So in harmonic there are two type of load, which is linear load and non-linear load. The cause of harmonic is non-linear load. So firstly, I will talk about linear load. What is linear load? The linear load is when a sine wave voltage is connected to a load of a linear element. The current will always be the sine wave or the same frequency. So as you can see that there are three types of load of linear, which is resistor, capacitor and inductor. So resistor. The resistor, the current and the voltage will always be the same as is finish is one cycle. Second one, the inductor. The inductor, as you can see from the graph, the inductor voltage is behind the car is finished first. Is finished first compared to current, which is makes the current is lagging the inductor voltage. So there are slightly different angle, phase angle between inductor voltage and inductor current. So for the capacitor, the current finish its cycle first compared to the voltage. So in other words, the current is leading the capacitor voltage. Next, the nonlinear. The nonlinear consists of power electronic switches, which is diode, thyristor, MOSFET, BJT and IGBT. So what from this type of switches, it will make a lot of harmonics, which from 3, 5, 7 and many more. So here are the type of load and the typical waveform and also the current distortion. So there are several that I can attach from this presentation, which is single phase power supply, semi converter, pulse converter, capacitive and many more. So the current distortion high for every type of load. So the next one is the impedance characteristic for linear and non-linear device. So as you can see, for the first one is the Volt-M graph for the linear device. So it's a straight line, and compared to the non-linear device, which is straight, then it will make a graph like this. So here the harmonics that I told about, which is from the fundamental, the third harmonic, fifth harmonic, seventh harmonic and ninth harmonic. So what exactly is the harmonic? So from the harmonic, they are from let's say third harmonic. So from the peak to complete one cycle, there are 1, 2, 3 peaks. So it times with 50, which is fundamental. So the fifth harmonic, seventh harmonic and ninth harmonic is also the same. There are 7 and 9 peak to peak to complete one cycle. So from the fundamental up until 9, we will add up to make a total, which is IP and also IRMS. So the next one is the implementation of IEEE 159. So what exactly is IEEE 159 standard? So it is to to reduce the harmonic in electric components. So there are several types in order to reduce the harmonic. The first one is passive harmonic filter. So it can eliminate or control lower harmonics such as 5, 6, 7, 5, 7, 11 and 13 harmonic. It also used by the 6-part drive. The next one, so here are the figure of passive filter, which is IC linear harmonic. Usually it connected in parallel with non-linear load. So it's rarely applied on higher order harmonics because it is not efficient enough to eliminate the harmonic. So usually when using passive filter, there are resonant frequency. Here are the equation to calculate the resonant frequency. The next one is as you can see, after we put a harmonic filter, so the output, it will be smoother, and so this is the current that we want for our equipment. So the next one is LT filter. The LT filter also same with the passive filter, but it do not present potential resonance to the network. It also unaffected by changes in source impedance. The next one is 12 pulse converter front end. It used 12 diodes instead of 6. Reduction of the 5th and 7th harmonic to a higher order where the 11 and 13 become the predominant harmonics. What it meant by predominant is the 11 and 13 will emphasize the harmonic itself. It also will minimize the magnitude of this harmonic but will not eliminate them. So the disadvantage of this converter is higher cost and special contraction. It also requires either a delta and delta Y transformer. It will also affect the overall drive system efficiency rating because of the voltage drop associated with the transformer. So the next one is LT pulse converter front end. This here are the figure of the converter. So basically it's the same with the 12 converter, but it composed of either a 3-phase to a 9-phase isolation transformer or a lower cost patented design of 3-phase to a 9-phase auto transformer. This is to create a phase shift of plus minus of 20 degree necessary for the 18 pulse operation, and a 9-phase diode rectifier containing 18 diodes, 2 per lead to convert 9-phase AC to DC. It is not only have a low harmonic distortion in the AC input current, but they also provide a smoother higher average value of DC output. So we can say that 18 pulse is better than 12 pulse. So the disadvantage also higher cost and special construction. It require either delta and delta Y transformer. It also affect the overall drive system efficiency.
Okay, application of IEEE 519 standards. For the first application, International Oil and Gas at Toronto, Canada. Problem that faced by the company first mitigates the harmonics and meets IEEE 519 standards. Customer is looking for energy efficiency and wants to comply with the industry rules and regulations. Third one, electrical infrastructure occurred at the customer ABC terminal. Installation of VFD to reduce consumption, and correction of the power factor to meet the IEEE 519 standards. The next one, how to solve the problem. Using the Acoustic VCS Plus allows us to use one filter to mitigate the harmonics of 7 with VFD ranging from 40 to 150 HP. Simultaneously, we correct the power factor of the DOR motors to 95%, eliminating the power factor penalty. supply a compact state-of-the-art power solution that meets all the customer's needs. The efficient PCS Plus eliminates the need for complex harmonic study. Okay, the second one, international FMB customers at Jawa Timur, Indonesia. Problems that are faced by company FMB manufacturing facing the key problem: high harmonic current level that need to be reduced, harmonic mitigation, correction of the power factor to meet the IEEE 599. And how to reduce the problem or to solve the problem? Install 3 times 200A accuracy to reduce harmonic current of both field. Improve transformer efficiency by reducing the temperature. Over-enhancing scattering of motors. Implementation results: reduce harmonic current level from 30% into 2%. And the third one, LED manufacturing plant in Asan, South Korea. Problem that had been faced: LED display manufacturing installed a lot of UPS and facing lots of the key problem. High harmonic due to UPS and manufacturing equipment. Harmonic mitigation, correction of the power factor, mid current regulation. How to solve the problem? Customer wants to mitigate harmonic and improve plant efficiency. Customer has 13 units of UPS. Install a cosine PCS 308 times 8K. Improve power factor from 0.79 to 0.85. And lastly, improve THD resulting in prevention of misoperation. The first one, cloud farms offer cloud and software customer in USB. Route the head base leading PF2 to several SMPS password mode. The second one, backup generators for 2. The third one, utility PF2 notice apply. Means current imbalance due to single phase SMPS. How to solve the problem? Simple installation is easy of use solution includes ecosystem PFP, integrates ecosystem PCS Plus, transform on the NV in switchgear, instantaneous reactive power for the displacement power factor corrections of the power factor. And this
is the purpose of the standard. The purpose of the IEEE 59519 standard is to dealing the harmonic situation because of these four reasons. The first one is the usage of the power converter become increased. Because of the usage of the power become increased, this make the harmonic also become increased. The next one is the network resonance are increased. This is also will affect the signal become harmonic. Then, because of the power system equipment and load are more sensitive to the harmonic. The last one is because of the electric cost becoming more effective when increasing the population of the non-linear equipment. Okay. The effect of harmonic is the commonly effect of the harmonic is first one is conductor overheating. This make the harmonic on undersized conductor or cable can cause a scaling effect which can increase the frequency of the signal. The second one is damage at the fuse and circuit breaker. At this situation, high harmonic current can cause fuse blowing in the capacitor bank. The result in a loss of reactive power supply to the system which can cause other problems. The next one is computer or telephone. This is because of interference or failure that happen at the communication technology. The next one is capacitor. The capacitor can be affected by heat rise, increase due to power loss and reduced life on the capacitor. This also because of the overvoltage and resonance can cause in dielectric failure or rupture of the capacitor. This is the other possibility of the effect of harmonic signal. The first one is motor. The motor can overheating or production of nonlinear uniform torque and increase of vibration. This will affect the harmonic signal. The second one is transformer, overheating and insulating failure noise. Third one is switchgear and cable. Natural link failure increase loss due to skin effect and overheating of the cable. Next is capacitor. Life reduced drastically due to harmonic overloading. Protecting relay also can affect the harmonic when the malfunction and nuisance trippings. The power electronic equipment can affect the harmony also when the misfiring and thyristor and failure of semiconductor device. Next is control and instrumentation electronic equipment, which is erratic operation followed by nuisance tripping and breakdown. Communication equipment or PCs, which is when the interference happens at the communication equipment. For the neutral cable, when the high neutral current with the harmonic frequency, neutral overheating and or open neutral condition can affect the harmony. The last one is telecommunication equipment, which telephonic interference, malfunction or sensitive electronic use failure of the telecom hardware.